Alright, so in this video I want to explain to you the difference between two things, and one of them was briefly mentioned in the prior video, something called a permutation and then something else called a combination. And I think the best way to explain this is to use the following two scenarios. I think if you understand the difference in these two scenarios, you understand this example. So I have in the middle there's a picture of, I'm a big track fan myself, both as a competitor and also to watch it. So I have a picture in the middle there of Usain Bolt. He's a world record holder in the 100-meter dash. This is a picture not of the Olympics, but that's the World Championships in 2009 in Berlin, Germany. And he's setting the world record right there. He ran a time for 100 meters of 9.58 seconds, which is quite a ways faster than any other person has ever run, including himself. I think the next fastest time is his own second best time, and that's 9.63. He ran that in London Olympics in 2012. But anyway, here are the two scenarios. Scenario number one is 8 people are competing in the Olympic 100-meter qualifying round. So if you've ever watched track and field, the Olympics, you know that before they have this final race right here, they have some qualifying rounds. And usually you have to come in the top 2 or 3, depending on the race and how many people are competing. And as long as you finish in the top 3, you get to compete. So it doesn't matter if you finish in third place, you get to go to the final. There's no advantage to finishing in first in the qualifying races. So let's suppose we have those 8 runners, and let's suppose that in the first round we have Albert, Bernard, and Charles, and they finish in that order. And then we have some other scenario where it goes Charles, Albert, and Bernard. Let's suppose we're hypothetically thinking of 2 scenarios in orders that they could finish. Scenario number 2 is now we're in the Olympic 100-meter final, and now the top 3, now the order does matter. Now if this happens, if Albert, Bernard, Charles happens, now Albert is really happy because Albert won the gold. If this happens instead, if it goes Charles, Albert, Bernard, now Charles is the happiest because he wins the gold. So hopefully you can see the difference. In this case, or in this case, Charles is not unhappy here. Even though he finished in third, he still gets to go to the final. In scenario 2, in this case, Charles is not as happy as he would be if he were in Albert's position, because Albert gets the gold. So in the case where position matters, which is this one, when position matters, we call that a permutation. Okay, the order does matter in this case. So the way that you would set that up is if there are 8 runners, you would say there's 8 people who could finish in first, times 7 who could finish in second, times 6 who could finish in third. And another way of saying that is 8 permutation, and then you're picking 3 people, 8p3, because there's 1, 2, 3 people right there. So that's what I usually think of it as 8 pick 3. The P can stand for either permutation or it could stand for pick. And the way that I remember the difference is position. The word position starts with the letter P, just like permutation. So when position matters, you're using a permutation. In scenario 1, we call that a combination. Combination means the position does not matter. It doesn't matter if Albert, Bernard, Charles finish in that order or Charles, Albert, Bernard. In either case, all 3 of them get to go to the final. And so there are far fewer possibilities because all of these are actually being double counted. So how many ways could we rearrange these 3 people? Well, there are 3 ways that they could finish in first, 2 ways they could finish in second, 1 way they can finish in third. So in the calculator for this example, you're not going to do 8p3, you're going to do 8 choose 3 or 8 combination 3. And what that actually equals is it equals the permutation number, but we have to divide by this number factorial. Okay, 8p3 divided by 3 factorial, that's what 8 combination 3 equals. Why are you dividing by 3 factorial? Because there are 3 factorial ways that you could arrange those 3 people. If you had the top 4 advancing to the final, in that case, if it were top 4, it would be 8 pick 4 divided by 4 factorial. And that's another way of saying 8 choose 4. Okay, so in the next video, what we're going to do is go through 4 examples, and I want to show you how to, first of all, decide with each of these. And I encourage you to pause it and try it because I think at this point you already know something about the difference. What we want to do is basically figure out, are these representing permutations or combinations? And in either case, how many possibilities for each? So we'll do that in the next video, but I encourage you to get a head start on that and try it right now if you feel up to it.